Hello everyone. In this video, we'll cover the meaning of a binary semaphore, which I would just call as a binary signal. It's a single signal, it's an indication to do something and anything according to your application. And we're going to go into a little bit of a code design pattern. How is the code skeleton? How is it structured to effectively use the binary semaphore? We're not going to cover how a queue of 1 with 0-byte payload can be a replacement. We're not going to cover what if the consumer is higher priority. We're not going to cover counting semaphore mutex. We'll save those topics for a separate video. So the basics of binary semaphore is that in FreeRTOS, you include FreeRTOS.h, Semaphore.h. You declare the semaphore like I have done on line number 17, semaphore handle type binary semaphore. Then you have a producer that's going to give the indication, the signal. And then you have a consumer that's going to receive an indication, a signal. We created the producer consumer tasks. So right now, this is going to run into a runtime issue. And what happens is that before we get the segmentation fault, FreeRTOS assertion happens on line number 1473 of Q.C. What's happening is just declaring this semaphore doesn't actually create it. So you have to say that X semaphore create binary. This API will actually allocate memory and create that binary semaphore so you can use it later with X semaphore give or X semaphore take APIs. Now, if I run this program, it will run correctly. It doesn't crash. So the program, what it does right now is a producer says, I'm going to give a signal, and the consumer is going to consume the signal, and then the program is simply going to end. Let's modify this program a little bit, where we give two signals after about 3 seconds. Okay. So now we have at tick number 0, you got a signal. And about 3,000 ticks later, we got another signal. This is binary semaphore signal, and this is the second signal. Now, this is a binary semaphore. It's a 1 or a 0. If we give a signal twice or 3 times, and we don't give the consumer a chance to consume the signal is only going to be given once. So if we compile this program, we'll notice that we got a signal. 3 seconds later, we got a second signal. So this signal was not given. If I surround this in an if statement and say, if not given, let's go ahead and not able to give signal. Again, in this video, I'm referring to the binary semaphore as a signal. So here I'm going to show you that if I had actually done some error checking with if statement, we will see that the second and third signal is not going to be given because it's a binary semaphore. So the producer ran quickly, and the first signal was given. It deposits a signal in this binary semaphore. The second and third signal was not given because it's a binary semaphore. It's a 1 and a 0. You can't you cannot accumulate items. It is not a counting semaphore. That's a topic of another video, but it's not a counting semaphore. So let's recap. A binary semaphore, you declare the handle like that. Static means it's private to this file. Then I have a producer that's giving the binary semaphore, a consumer that's consuming the binary semaphore. And a binary semaphore can only be given once until a consumer consumes it. The applications of this might be, your producer could be a button press. So you don't want to handle the button press inside of an interrupt. It could be maybe there's multiple triggers to update an LCD screen. So this could be a trigger to update LCD screen. And then the consumer in this example could be, if signal is given, we will update an LCD screen. So that's an example. So let's recap this video again. We covered a binary semaphore. It's a binary, so that means it's a 1 and a 0. It can only be given once until it's consumed. And don't forget to create the binary semaphore like we have done on line number 49. Thank you, and let's cover more topics in other videos.